Hello again. This is Philip Steiger at thebest3d.com, and in this quick tutorial I'd like to first start by changing the size or dimensions of a new image that comes up by default. So I'm going to go to my window menu and change settings here, and what I'd like to do essentially is set the default size to be a little bit wider, 1280 by 768. That is actually one of the presets we have, but I'd like that to be the initial size when Dog Waffle starts. So I'm going to save that, and now let's see if I create a new image, and it still has the current size, so maybe that'll be the next time around when I start the program. Let's move on to the next thing, which is 1280 by 768. And what I'd like to do is a little animation that I will then try to show some ways to make it slower with ultra slow motion interpolation. So to begin, what I'll do is simply generate some sort of an animation with the PuppyRay ray tracer, which means we need a what do we need? A plasma noise maybe for the terrain. And you know what? Let's put that into the swap buffer. So copy that into the swap image. That becomes the background. Actually, no, that's not the background. It will be the coloring. But we will use it for displacement. And then I will load another into the main image. I will load the where is it? Brick texture maybe, or grid. Let's start with a grid and have something like this. Actually, you know what? I wanted something more like this, but without the clouds showing. So let's go and undo this and render. There you go, something like this. So here's the grid. Go. And so now I'm using the image that still exists in the swap image there, and I'll use that as a displacement map. And that displacement map will of course look something like this here, displaced by swap. I'll use the color twirl displace and see what that gets me. Okay, so something really wacky, and perhaps I'd like to blur it a little bit. Let's go to the blur filter for bokeh or Gaussian blur. There you go. And then at that point we can actually, because we now have those gradients going from the dark blue-green to the bright white, but with some shades in between, we could go and apply something like that, coloring the gradients. Let's go to the sweep editor and the color gradient, maybe some of the gradients that we have, the presets. I never remember which ones, maybe these here. I'm sure some of these will work just fine. Let's use this one here, for instance, and map that to the current image under the color map the current gradient. All right, so it's really odd, but what we'll do is we'll use this, copy that into the color buffer, and that would be right here into the color. Excuse me, the swap image, and then we have we can go back here and keep this one. So we now have a combination of both images, the colored images, and this one here, which will serve as a grayscale. Perhaps we might want to store that, so let's go keep this one here, switch with J shortcut on the keyboard, and jump to the swap image, and then store this one as well. And so we have these two, and jump back. So now we have this to create an animation from. Let's go and create an animation, I don't know, something like 200 frames maybe. There you go. And first thing we'll do is store this one, because we might need to get back to that. So let's store this perhaps in memory really quickly. There you go. And there's really not much animating here, but it's a sequence of frames, 200 frames. And the next thing we'll do is animate this with the PuppyRay ray tracer. Will fly across that terrain. So let's go to the transform, PuppyRay, and let's do it fast. So let's go to use the GPU version. And this terrain is a little bit odd. Well, actually no, it's just pretty nice. Let's enable the global illumination right there, so that gives us a view into the shaded areas also, with the shadows still being cast. Maybe we can use the view controls here to rotate the camera a little bit to the other side and increase the illumination level from the global illumination. And so now what we'll do is simply have a little camera movement. So I'm going to store for the first keyframe here, I'm going to store that keyframe, and then I'm going to the last view, last position along the timeline, scrubbing through that or just jumping, right clicking here. And then I'll make sure that I move the camera in this direction. Okay, about this much. Maybe we can even change a little bit which way we're looking. And also, again, back to this with the right button, change the elevation. So we get a little bit of everything here. Move up a little bit and even change the angle like so. All right, keyframe that. So we now have two keyframes, one here and the other one here. And I'll simply animate this by going to select, during the rendering of the animation, I'll select maybe high quality. That'll be good enough. So let's go and click animate and select high quality and click render. So what you see now is the rendering in progress. And it's really one thing I wanted to show you is that this actually can take quite a while. All right, so if you render an animation of, I don't know, 200 frames in this case, and you have the highest quality settings, it might take 10 seconds per frame, maybe even a minute. And especially if you don't use a GPU version, or if you have a lousy PC with no strong graphics card, no good acceleration on the GPU side, it's going to take a while to render that. And what I'd like to do is show you, okay, what now if you have rendered even just 10 frames or 30 frames, right? I'm doing 200 here just so it's extremely long. But what if you have an animation of just 30 frames, but that's not enough? You need, because 30 frames, if you play it at 30 frames a second, it's going to take 1 second and it's over. What you want to do, let's say you want that to be a slow animation, a super slow motion that takes 10 seconds to play at 30 frames a second. We're talking 300 frames here. And 300 frames, if you are rendering them at 10 frames a second or even at a minute per second with the non-GPU version, this can just take a long time. This is also something you might experience with other programs, not just here with Dogwaffle. You might be using Carrara, my favorite 3D program, or you might be using anything else that when you render your final image, it may take a minute or hours sometimes to render the whole thing, you know. So, but then you realize, oh no, I actually need to redo many more frames and I need to make it slower. So here's an alternative. You can do basically time stretching or interpolation through the frames, but with what we call the motion prediction module. It's using motion estimation. It's determining where each of the parts of the image are moving. So I'll show you that in a second. In fact, I don't need to wait for this image to be completely done, so for this animation to finish. What I'll do is I'll stop it and I'll call it done. And so we have some of the animation done and some of it is still at the original here. So what I'll do is I'll cut this off. I'll say at the very end here, I'll say set the in marker, let's go to the out marker, call this off, and we can see it actually here with the blue highlight. There it is. We have the in and the out marker set. We can right click on this and say delete block. So now it's deleting all these unused frames, and we now have the animation like this here. Right. Okay, so this animation, first thing we need to do is store that, because we'll probably get back to it a few times. So let's make sure we store that one as well. This one we might not need anymore. Let's free this. So we have this animation stored here. We can scrub through that to verify. Yep, there it is. And so maybe at this point we realize we really don't need it that big. Maybe we need it only 640 by 360 or something like a little bit smaller. And so one thing to do, let's first see what the size really is at 100. This button here shows 100%. And so yeah, let's say this is a little bit too big and we want to resample it down a little bit. So we could go to resample right there under the image menu and say, for instance, we need it 800 by something. So let's make sure we keep the constraint checked on here, and then say this is going to be 800 by whatever, by 480. Okay, and let's go okay that. So it's resizing the frame sequence, every frame, every image of this animation. And once that's done, we probably will want to store that one too. So we have here now a nice animation, but it's too short, right? If we play this FPS here, frames per second, at 30 frames a second, and we play it like this, let's say we want this to be even slower, right? So we have a, what's that, 2 seconds? We have 134 frames. At 30 frames a second, that's just barely over 4 seconds. Let's say we want that to last about 15 seconds. And maybe there's going to be a dogfight or a chase, you know, some fighter planes or some UFOs chasing or something that we composite on top of this later on. But what we have going right now is that we need to slow this down. And so first thing we'll do is save it again. Actually, you know, you might save it to file, but I like the new store animation option here, to disk or to memory. Let's go to memory here. And so this is our working platform now at this point. And so what I'd like to do is show you the motion estimation based animation or interpolation, because you know there's two ways to animate to slow this down. Right click on this and you'll see the time stretch. And that might work for some types of animations. Maybe we'll say, let's make it 4 times slower, right? So 4 times more frames with frame blending. Okay, that. And that's a pretty quick technique, but at times it will introduce a little bit of jitter. Now this one here might work just fine. Let's have a look. Yeah, not bad at all. You see a little bit. Actually, this one here would probably work fine with this technique. Right, so this motion interpolation here is not necessarily needed. I still want to show you the technique though, because you will find some cases where the video really is showing too much, what do we call it, jitter or strobing effects, where there are a lot of bright pixels next to dark pixels, and we don't have that here so much, and maybe that's why it's really not too bad with the regular time stretch technique. Frame blending will work here. But you will very likely find scenarios where it's just not working too well because it's giving you that strobing. So let's go and store this one as well. Animation store to memory. And now we have 2. So I'm going to restore this one. That's the original one that had only 134 frames. And this time what I'll do, you know what? Let's make it even shorter. Let's pretend we only had half that many. So right click on that. Time stretch, this time we'll divide by 2. Right, so we have only 67 frames, and we won't do frame blending, so we really just cut off every other frame. There you go. So we have now half the frames. It's going a little bit faster now, right? It's moving faster each increment per frame. And that may be really your true scenario. That may be what you have if you've taken your 3D program and did some rendering at very high quality, and it took maybe an hour to finish it over just 2 seconds long at 60 frames total. In fact, I can delete a few more here. Let's delete 1, 2, 3, 4, 5. So I now have 60 frames. Oh, 61. Let's delete one more. There. 59 is the last one. 0 is the first one. So we have a total of 60 frames. Let's store that one. There you go. Store to memory. All right. So this animation is a short one. We need that to be a longer one. And so let's have a look at how to do that with the other technique. The first technique was to use the time stretch and to do the frame blending as part of that. The other technique is to use a filter in the animated filter collection, and that one is called the motion prediction module. It's using motion estimation. Now what that means is that it is slicing the image into a bunch of small tiles. You can actually click dry run here to do a sort of a test without actually it being applied. And what you do is you set the search distance and you set the grid spacing. First, the grid spacing here is 12 by default. And what you can see when you click that, you'll see it in blue. You'll see a grid being overlaid on top. And that grid identifies a bunch of squares. Each of these little squares is then going to be tagged with a motion tracker. And the image it contains is going to be tracked. It's going to look for that same image in the next frame. So as we scrub through the animation, it's going to want to know, where did that image go? Where did each of these tiles go? And we can, of course, we know it's moving, or we expect it may be moving, and we can tell it how far to look for it. This is what this does. The search distance says, well, I know it's not moving too far, but we need to be able to look for it somehow and find it. Now, if it's moving too fast, it's hopeless. We're not going to be able to find it. So there's a limit to that. But if it's reasonably slow, or small increments, we should be able to find it, and we can tell it here not to give up, keep looking further if it doesn't find it, or we can tell it, okay, it should be within this range. And then what we'll do is maybe we'll leave this one here as 12 as the default. We are in dry run mode, and we are now going to click go and do a test. And so what this is going to do is produce, out of the initial 60 frames, we'll now have a total of 170 frames. 175 frames, so roughly 3 times more. And in many cases, this will look good. Not always, right? This kind of movement is good. There are other types of animated sequences, movements, where it's not so good, especially if the topology changes drastically. But this one here is definitely a case where it will work quite nicely. Also, if you do things like panoramic sweep, going from left to right, or right to left, or up and down vertical sweeps, those type of sweeps are really good, because the search for where the individual tiles move, it's going to find them just next to each other, right? It's going to keep moving sideways as the panoramic sweep is happening. So that's a really good technique to use. And if it's not moving too fast, you can make the whole process even faster by reducing a little bit how far you want to look for that movement. Now let me show you what happens if you don't give it enough, though. If you only go a little bit here and say go, then you might miss some areas. But you know what? This is actually still catching quite nicely. So I think we're good here. What you might want to do is give it a refinement pass. And that's now taking a little bit longer, and for each of them it's a little bit choppy. It appears to be choppy, but it's really just taking a little while to calculate it, figuring it out, and then it's animating through just 3 frames, so it's going really fast at that point. The key thing is that it's telling us it's actually going to look pretty good. So what we can do next, maybe stop it here. Next we can say, okay, we actually need more frames. We want 9 times that many. Let's see what that looks like. Click go, and we're still using the refinement pass. And I think this is gonna look really good. Alright, so the next phase here, stop that, is to actually go, and sometimes you do other things, like if the pictures are very noisy and there's a lot of animation on there, you might want to use a stochastic average of 5 frames, 2 ahead, 2 following frames, and then the one we're actually on, to look for that particular moving target of each of those tiles. But that will just take extra time, and so I'll skip that for today. There are also other options here to go look for subpixel accuracy, and so depending on how sophisticated your animation is, you might need to explore some of these options too. You can, for instance, also learn a lot from what's going on here with the motion, showing the motion vectors, and actually as arrows. When you do that, it will show you little arrows or markers indicating in which direction things appear to be moving. Right now, there are some parts here that don't seem to be moving much at all. That's why you don't really see much highlights here. But there are other parts that have a nice long vector because it's moving a little bit faster. This is also a good way to figure out, well, how long do you need that search distance to be? Right? If there are no fast movements, there's no point of for the search distance to be this big. All right, so you should still be able to catch everything, even if it's that little. Alright, so now that we've done that, we can go and disable the arrows or the show motion, and we don't necessarily need to scan for dropped frames. There aren't any in this case. And then we go and undo the dry run and actually make this so. So apply that, and we will have an animation of 523 frames. Right. So keep in mind, again, the original was something that took a lot of time. And it may have taken actually a significantly longer time than it did in our case to really happen. And then what we're doing here, the last frame, by the way, the first frame of the motion predicted result is going to be a copy of the last frame. So we need, that's a little side effect of our algorithm. Let's just go to that first one and delete it. All right, so now we see kind of where it started from. And again, this is not going to look perfect always. Depending on how far you set the movement, and if there's repetitive patterns in there, it might lock on to the wrong place if you search too far or not far enough. So you might occasionally see a little bit of a wobbly or a swimming, and that's when it tells you you're not quite done yet. You need to experiment with this a little bit more. And as I said, sometimes you really don't need to use this. Sometimes the other tool that we had earlier, the frame stretch or time stretch with frame blending, is just fine. But this one here is definitely something that will also help sometimes avoiding the strobing effects. Now you might still see a little bit of noise here, or some strobing, not strobing but some flutter I call it, and especially along the edges. If things are moving fast and high contrast, you'll see the edges give you a band of unusable data. Just around here you see it quite a bit, because that's where it's moving the fastest. So what you could do is simply zoom in a little bit now, or crop, right? I mean, if this image is still bigger than what you really need in the end, you could now use the crop tool, for instance, right? You could say, let's go and take the crop tool and zoom down a little bit, zoom down on the crop there too, and perhaps position it to the upper area, something like that, and then right click to crop, and it crops through the entire animation. Now, one drawback with this, though, be careful, when you crop like this, you're not seeing the exact dimensions, and it's certainly not keeping the aspect ratio. So you may need to go check the image here under info, image info, and see that you don't have any odd dimensions. Yep, and here I have it. The height is now an odd value, 363. And that happens a lot when you do manual clipping or cropping. You know, if you don't check it, you don't have necessarily even dimensions. Why is that of any concern? Well, because if you save this as an AVI, or maybe later converted to other video formats, many of these video formats don't like odd numbers, and they'll simply won't save it, or they won't be able to play it back later if it was saved with odd dimensions. So one thing I'll usually do here is I will save it, and then resample it like this, and say, for instance, I want 360 here, 360 on the height. Now that's giving me 724 on the width. You know what, I might change that to 720, but if I change it, then it's going to change the height, because I currently have the aspect ratio locked here, or constrained. So first thing I'll do is I'll uncheck this, and I'll put the right value in here, 720. And nobody's going to notice that it was squeezed a little bit. It's just 3 or 4 pixels. 720 by 360. Okay, that. And then at this point, I will have my animation pretty much completed and nicely smoothed. Remember how short it was initially? It was just 2 seconds long, and it went through pretty quickly. Well, now we have an animation that we can really look at for a long time. This is what I'm talking about. You're spending time rendering something for just a few, maybe a minute or maybe an hour if it's a really high quality rendering. And you only got 30 frames or 60 frames, and you need many more. Well, the motion prediction module can actually probably give you a decent enough animation of stuff in between, those frames in between, that you don't actually have to render this for hours on long, right? If it took half an hour to render 60 frames, it's going to take 4 hours to render 8 times that many frames, and you just may not want to wait that long, or you may not have the need to wait for that. Especially if this is actually going to be simply the background, and it's going to be blurry. Maybe you add some motion blur or some other Gaussian blur to make it a little bit fuzzy, and then you have your other objects in the front that are going to animate, like some spaceships or something like that, some dogfights from fighter planes. It really, that's something you want to incorporate into that entire workflow too. You want to think, do you really need it that high quality? When you render it, is it really necessary for it to be rendered at the highest quality? The final render is not always necessary. Alright, well, thanks for watching this. I hope this introduced you to Dogwaffle from a perspective that you can use with your video work or your 3D animation work. And that's what this is all about with PD Howler. Thank you very much.